Hello everyone, welcome back to another Kwyll update. It's been some time since the last actual update. I didn't realise how long I'd left it, but it was October 26th I think was the last normal progress update. I have done another video, or a couple of videos in between, one specifically about the making of Santa's Lost and Found, but this is the first one for quite some time that just goes into the details of what's been changing in the Kwyll tool, under the hood, on the Spectrum, and so on and so forth. So it's been quite a while. There's a lot changed, so for anyone who hasn't been following on the Discord or taking part in the beta, there's going to be a lot to cover here. I'll not go into too much detail on each one. If anyone wants any more information on the changes, then just by all means pop over to the Discord and ping me, and I'll go into more detail. But given the amount that I've got to cover, and I don't want to be here for hours, and I don't want you to be listening for hours, I'll whiz through them fairly quickly and only focus on some of the more complex ones in any detail. I'll start by covering things that are in the editor UI. New features, new tools, and so on, in no particular order, just as I pulled them out of the Git log. And then I've separated out things that are related to logic, in particular things like new nodes and changes in the way that works. And then at the very end I'll just go into some detail about some statistics of how things are looking on the Spectrum side in terms of memory and performance and so on and so forth. So without any further ado, let's dive in Kwyll itself and look at my list. So starting off on the list, I've got a feature which came up because of the work I was doing on the game Mind Out 2. A lot of these things have come from the focused work I've been doing on Mind Out 2, which is due for release fairly soon, and problems that I encountered while working on that. I won't show Mind Out 2 here because I want to keep it for a later video, but the feature is basically in the map editor. When you normally drag a room or a room onto the map as a location, you'll get the tile map that exists in the room editor, whatever you define here. Now, if you haven't created any tiles, as is often the case if you're creating a game that has dynamically created rooms, or rooms that configure based on some logic, which is a technique that's used to optimize memory use, what you'll see in the map can often be just empty rooms, because the tile maps are only populated at runtime using brushes and logic to modify the tiles based on various configuration things, which makes it very difficult to see what you're building when you're creating your map here and joining rooms together. So what I've done is I've implemented a way where when you're in the map editor, it will, when it needs to, it will actually fire up behind the scenes. You don't see this behind the scenes. It will fire up a simulator, a hidden simulator with no display, jump to that room, which will then trigger the on room entered code, which is where you would put your any logic that you want to configure the room and paste brushes and make the room look how you want, and then it'll take a snapshot of that, and that's what it shows in the map. So I can show this working fairly quickly in the I've modified the old Attic Attack demo. So if we go to the rooms, for example, here, and select our forest room, you can see actually in the room there's no tiles. There's a bunch of markers and objects, but there's no tiles, and this is because if we look at the brushes, the rooms are configured by placing these brushes into the four corners in some logic. If we look at the logic, we've got, I believe, this one here on room entered. So what it'll do is it'll read the variables for northwest, northeast, etc., and paste a brush, the correct brush, into the room. So what you would normally have up until now is an empty room when you go to the map editor, which, as I say, is not ideal. So what it does now is it will actually render those brushes, it'll run that code and then take a snapshot. So if we select our room 1, you can see this has got, if we look at the variables, it's 0, 0, 0, 0, so it's using the 0 brush index in each corner. If we change one of these, so we change the northwest, which is this one here, to 1, you'll see immediately it changes. It's re-rendered the room. There's still no tile map in here, but in the map it's re-rendered the room to use the new brush by running the code. So that just makes it a little bit easier to see what you're working on when you're using this technique of dynamically created rooms, which is really useful to save on memory. So that's that one in a nutshell. Moving on, you probably see some of this already here. So I've updated a bunch of these UI elements here to give a little bit more information. This is one, the map locations. So before this was just a simple, the name, and that was it. But now we've got the index, which is important if you're going to be using the index to jump to locations from code, so having those. I've taken out the index from the display because it was just, I didn't think it was necessary to have it in both locations, and instead we've got the room names there, and then you've got the room type that it's based on, and always been there. You can go straight to the room itself. So that's that one. There's in the tiles, I've added some more information to the list UI so that you can see these extra information panel underneath each tile. So this has the ID of the tile, which is just the index, and again that's useful in Logic to know. So if you're changing a tile from Logic, or you're looking for a particular tile or something in Logic, knowing these indices is really important, and you don't really want to count 1, 2, 3, 4, 5, so it just displays that to make it a little bit easier. And the green number to the side to the right is the type, if it's been assigned a type. So if you choose a particular tile, so for example the key, you can set it a type, 0 to 7 I think. It's very limited scope, but if I set that to 3 for example, you'll see it just shows 3. And this again is useful in checking tile information in Logic, and also there's a new feature which I'll go into when I come to the Logic side of the update, that number is really useful. So that shows that in the list, just to give you a bit more information. And also over here in the brushes, you may have noticed when I was showing you a moment ago, there's a similar panel underneath each brush. Now the first number is the same as in the tiles, so it gives you the brush index, which again, excuse me, again very useful for or imperative for using brushes in Logic. When you're pasting a brush, you want to know which index, so it's just really easy to just look it up in here. The T, A and the C indicate which data has been captured into the brush. So when you create a brush, you hit the select tool and you select an area, and then you create a brush, and it will capture anything in the tile map in that region, including anything you've pasted for tiles, using this tool, any colours you've painted into the tile map, and any collision information you've painted into the tile map. It'll capture that. The more information you capture in each brush, the more it costs in terms of memory. So if you want to be very careful about how much information you capture into a brush based on what you really want, it's good to know what you've captured. So this will show you that this brush only has tile information in it, nothing else. The attributes and the collisions are greyed out, so they're not selected. Whereas this brush here, for some reason, probably a bug in the game, not in Kwyll, has captured some collision information as well, so I'd need to look into why that is. And then down here you've got the doors, which are based on a single tile. If we look at the tiles, we've got one set of tiles for the door, but then we colour them in the tile map before capturing, so this one has tiles and attribute information, so you can see what you're saving there. Very useful. Okay, that's that one. Moving on. So another thing, I just sort of touched on selection. So selection, up until recently in the tile map editor, has been only for the use of creating brushes. You select an area and you add a brush. But I've now enhanced that a little bit. So before it was a mode tool, it's no longer a mode tool in exactly the same way as all the others. If you switch mode now, the tile selection remains. It would have disappeared before. So you can now select and reselect, or you can clear it if you want it out of the way just by right clicking. That's fine. But what it allows you to do by being persistent in that way is, if I switch to, for example, the move to tool, actually let me show you what the move tool does first. So if we switch to the move tool with nothing selected, it moves the whole tile map. I think you can guess what's going to happen here. If I select something and use the move tool, it allows me to move just that. So it's like a very efficient cut and paste, so moving sections around within your tile map. So that's another useful tool for the tile editing. I'm just sort of looking at my list here, so I will actually skip one and come back to it in a second. So another thing related, so we're sort of in the same area, I've improved, and this is an underlying thing, I won't be able to demonstrate it, but I've improved the way that tile map information is stored in the exported game, using a new algorithm for the compression. And so it makes it a little bit more feasible for you to actually just paint your rooms with just tiles and colours and so on, whereas before you had to be much more careful about that and try and use brushes where possible to save on space. This gives you a little bit more potential to actually just be a little bit more straightforward and just paint your rooms. The average saving across all of my test content, if I did a pass before and after on all the test content, was about 28% saving in overall export size for tile map data. So that's a useful addition to give you a little bit more room to play in the available memory when it comes to tile maps. So now a step back. So if I'll clear this out and start on a blank to show this feature. So if I make this screen not a game screen, so that it hides away the blue game window. So this would be a menu screen, for example. Now previously, if you wanted some instructions or something on your screen, on your loading screen or your menu screen, you'd have to create multiple instruments for each line, which not ideal. So let me just show you what I mean by that. So if we create instrument, call it line 1, and make it a text, which we have none at the moment. Just expand that out, and then we'll duplicate it and move it down. And then if we go to our data and add a couple of text strings, and then go back to our screen, we can change this one to this is how you would have to create a multi-line any text that covered multiple lines. So obviously that's not efficient. It's not efficient in terms of storing data in here. It's not efficient in terms of typing data in. It's a bit of a pain. It's also not efficient in terms of memory, because each instrument has a fixed overhead. So what I've done now is implemented the concept of multi-line text. So obviously in this editor you can only edit a single line, but you've got this button over here, and if you edit in here, it brings you it brings up an editor that allows you to edit text over multiple lines. This down here is just a quick a ruler, effectively, to show you how much space you've got on the screen, and it uses a fixed width font, Spectrum font, so you can see roughly what it's going to look like. So when you save that, it shows you in grayed out, so you can't edit it in here anymore. You have to go to the pencil icon to edit it, but it shows you the rows in there. And then in your text editor, in your screen editor, you can create an instrument now that is over multiple lines, which you always could anyway, just wouldn't honour it, and set the text to that one, and it will just allow you to have a single instrument that has multiple lines of text. So unfortunately there's no centering or anything like that, or no organisation of the way that it renders the text at the moment. It just renders it exactly as is, which is the reason for the ruler down here. If you wanted this centered, you could easily use the ruler to help you center it. So there's a bit of an overhead in the storage of these spaces, but it does allow you to do that, and it will respect that, and that all works on the Spectrum too. So that's multi-line text instruments. Okay, jumping forward a little bit now to something that happened that was added fairly recently from a request from a user. I'll load something up to demonstrate this one. So this is in the sprite editor, so you can see immediately there's a new feature down here in the sprite editor. So before, if you wanted to understand, so you can edit your sprites in here as normal. Before, if you wanted to know how an animated sprite such as this one, so this is a left-right walk sequence, if you wanted to know what that animation looked like, you'd have to go into the object, player, animation, and you'd add that animation in. And then if you wanted to make a change to it, if it didn't look quite right, you come back to the sprite editor, edit that frame, go back to the object and see what it looks like. So now you've got this temporary thing here. It doesn't save anything, it's nothing to do with the actual project, it's just a temporal tool. So you can add, it works in exactly the same way as this editor here, but just within the sprite editor. So now I can drag this one onto there and this one onto there, and I can see what it looks like. I can select the individual frames to be edited from there, so you don't have to go back over to here. You can do it all from within here, and if I want to make a change, it changes immediately, so you can see exactly what you're doing. So this is another tile map editor change. Again, anyone who's familiar with the tool will see it straight away, and it's here to do with these layers. So before we had layers here, which were grid, tiles, collision, attributes and brushes, and those are the only ones. Now the way this operated was a little bit confusing. So basically, if you turned off tiles, it would turn off all the tiles that were displayed wherever they came from, whether they were part of a brush, painted into the or painted into the tile map itself. Similarly, collisions, it would turn off the display of all collision highlights, whether they were so this snow one has collision information built in, so that's why you get that green highlight there. So if you turned off the collision before, it would turn off all collision highlights irrespective of where they came from, so it was very difficult to track what you were doing. So what it does now is there are actually conceptually 3 layers of source data in a tile map. There's painting stuff with this tool, these tools here, so painting tiles, there's painting attributes with that tool there, and there's painting collision, that paints directly into the tile map. And then you've got painting brushes, so if you paint a brush, paste a brush, it goes into this. So you've actually got 4 layers, I misspoke. So you've got 4 layers. You've got tiles, attributes, colours, collisions and brushes. So these 4 here now directly turn off those layers, turn on and off those layers. So if you turn off tiles, it only turns off the tiles that you've painted with this tool into the tile map itself. If you turn off collisions, it only turns off collisions that you've painted. So these ones here I've painted manually using this tool into the tile map, so it will turn those off, but you still see collision information that are embedded in brushes and as default values in tiles. And attributes, similarly, it turns off any attributes. There's nothing I've painted in there with the attribute brush, so it doesn't make any difference. And if you turn off brushes, it turns off everything to do with the brush. It turns off the collisions, the attributes, and the tiles. So you can see this is stuff, when you turn off the brushes, what's left are tiles that I've painted, collisions that I've painted, and possibly any colours. So you can very quickly see where how you've constructed your tile map. And in addition, there are two new more layer flags or triggers on here to turn off objects and to turn off markers. And the reason for that is if you've got the object showing and you try to paint a tile, so I try to paint some bricks there, it will automatically select the object first, so it's very difficult to paint over. You have to, before you had to move things out, do some painting and then move it back again, which is not ideal. So now you can just turn the objects off and paint and you're fine. So, and then the same for markers again, just to keep things clear so you can see what you're doing. Now that means that before you had the ability to turn off all the collision markers and highlights if you wanted to see what the screen looked like without any of that stuff, and you don't have that anymore because collisions can come from multiple places. So I've introduced the idea of channels, trying to borrow a paradigm from Photoshop and similar paint packages. So you've got layers, which are layers of data, and then channels are tiles, collision and attributes. So if you click on tiles, it stops displaying all tiles wherever they come from. Similarly for collision, so it just hides all of the collision highlights and attributes, so you can turn off all the colours wherever they come from. So for example, it's quite useful to be able to turn off the collision, turn off the markers and the objects, and turn off the grid, and then you get to see what the screen looks like without any objects and so on as you're constructing it. So the logic debugger, which is in here. So before previous version, the debugger was embedded into the data view. Now it's got its own separate tab. I have created a video which goes into a lot more detail on this, so I'll link that somewhere so you can go and see that if you want a little bit more detail. I'm just going to gloss over it fairly quickly here, but it has been refactored heavily to be a bit more powerful and a bit more useful. So I can show you an operation very quickly. If I just go to the Santa object, go to logic, and if we go to our main, we've got somewhere, if I can find it, what's this? Let's see if we can find the movement. There you go, this is movement stuff. So this is all left, right and up. So if we set a breakpoint here, for example, and then go to our preview and play, and then get into the game, see it jumps straight to our logic in here, and that's pretty much as it worked before, but it works properly now. A lot of issues have been fixed with the way that it operates, so it's a lot more predictable. I've added this feature down here which shows you variables on the thing that you're debugging. So all of the variables on the Santa object and all the global variables, which are all the things that you have access to from within logic, so you can see those without having to jump back to the data view and scan through lots of stuff to find it. And the single step goes through much more neatly. Now you can see what it's doing. It doesn't jump around. If a node is visible on screen, it stays. It keeps the view as is, so you can easily see, and only when it goes off screen does it zoom over to bring the relevant node into view. So hopefully that debugger is a little bit more useful. Hopefully people will start to use it a little bit and feedback on what it does well and what it doesn't do so well. As I say, there's a video that goes into a lot more detail about how it works and why it works that way, and I'll link that somewhere for you to go and have a look at. So one of the things I realised when working on Santa, I think, and possibly on MindOut 2, was that quite often a room definition, so these are room definitions, had very similar or identical, in most cases, logic. But because a room definition has other things in it, such as the tile map and objects, I found myself having to duplicate that logic on each room definition, even though it did exactly the same thing, which is obviously very expensive and wasteful. So now what you can do is, for each room definition, you can choose whether to have its own logic. See, all of these use the logic from room 1. So when you go to this room, it doesn't show any logic editor because it doesn't have its own logic. It just shares the logic from room 1, as indicated here, and if you click on that button it takes you to room 1, and there you can edit the logic. So that saves on export. It will only export one set of logic and then just reference it from all the other rooms. So again, you can see down here another feature been added to the logic editor, and this is tabs. I'll show you it on Santa because I've already done some separation here. So basically you can have, it was getting to the point where some of the more complex objects or rooms were becoming unwieldy with massive graphs or massive lots of different flows on the same graph. So I've introduced a feature that allows you just to separate all the logic on a single thing into multiple tabs. So this one here, I've created a tab, called it chimney, and then just moved all the logic related to the chimney handling into that tab. So if I go back to main, for example, you'll see there's a bunch of logic in here. There's a lot of logic in here still that could do with organising. So all of this up in this top corner is to do with movement. So I could create a new tab and then just select a single node. All I need is a single node, and move that to the new tab, and it'll move it and anything connected to it into the new tab. So that's just a way of organising. Now you can right click on the tab and there's a bunch of options in there, including changing the name. I can't do that live, unfortunately, because a bug in OBS means that it messes up the capture. So trust me, if you right click on the tab there's a way of renaming it. But that's basically how tabs work. So moving on from tabs, we've got import and export. So I'll start a new scene, a new game. And if you create a new object type, and in the logic you'll see there's a new button up here in the main toolbar, which is for importing. So what I've done is, alongside the work done to introduce tabs, which was a method of controlling or organising your graphs. I've introduced a way of importing packages of logic nodes and flows, importing and exporting. So in the built into Kwyll, as it's released, are currently just 2 of these packages, and hopefully over time these will, the number of packages in here and the categories will improve and grow as people come up with suggestions or things that they'd like to see in these pre-packaged logic graphs. But we've got a couple in here just as an example: a 4-way movement and a platformer controller. So for example, I import the platformer controller. If I click on it, it tells you what embedded in the file. There's a little bit of short description, and I can import that, and it would create a new tab appropriately named based on how you exported it, with everything necessary to do a platform controller. So you've got the movement, you've got gravity, you've got landing, and all sorts of stuff. So that's all in there. That just basically will make that object into a player type object that has basic platformer controller features. So this is a really easy way, if you're building a platform and you don't want to get into the complexities of creating your own logic, even if it's following the tutorial, in the documentation. It's still quite long-winded. And if you're not interested in learning that, or you just want to get moving quickly, you can import this logic graph and immediately get a player, a platform controller player working. And you'll notice it actually introduced all of the necessary variables as well. So saved with the exported logic graph is all the information necessary to rebuild it, which tab to put it into, which variables are necessary, and it will rename these if there's any clash with what you've already got, and fix up anything in here. So it's all nice and clean. So it just allows you to import a prepackaged set of logic and get going, but still means you have the ability, if you want to go in and change it or just understand it. It's not hiding anything from you, it's just making it a bit quicker to get up and running. You can export them too. Again, I can't show you this unfortunately because a bug in OBS means that if I right click on here at any time, the screen capture of my Kwyll window gets messed up. But alongside the ability to edit, you can export, and then you can just give it a name, a description, type in a description, and save it as a file to your disk. And then in the import, you'll notice you have not only the ability to import from the prepackaged ones, but you can load from a file on disk, so you can save your own, and you can share them. So you can share them with other people. Maybe there's a potential in the future for some sort of central repository for people to post their useful snippets of logic. Okay, next up is portals. So to demonstrate that, I've loaded up one of the sample games and focused in on some logic here. So you can see in the middle here we've got a bunch of wires coming from this object position node to various different places. This isn't a particularly bad one, but it does show how the graphs can get a little bit messy quite quickly. So portals are purely an edit time tool to alleviate some of that mess. So I'll show what you can do. So at the moment we've got X and Y going into these two maths nodes, and then over to this spawn object node as a position here. So if we add a couple of portals, portal ins, which is the opening of the portal, and you can give each portal a different name. So this one will give X, and then another one for Y. It can be any name you like. They're designed to be as small as possible so that they're unobtrusive. So if we just disconnect these quickly from here and instead put the X into that portal and the Y into that portal, we can keep these right over here out the way so they're nice and tidy. And then up here where we were using it before, instead of having to make the graph unnecessarily big and sprawling to accommodate the fact that you've got these wires going in, what you do is you place an out portal, which is the opposite end of the portal, and that out portal can only be for any existing in portals. So we choose the in portal that we're interested in here, which is X, and create another one here and choose Y. And you can see straight away that keeps it a little bit tidier. And then down here again we can create two portals, one for X and one for Y. Put them into there. Now these don't have any performance or memory advantages at all. It's effectively as if there's a wire going between here and this one and this one, and so on. So next up is array variables. So I'll show that by creating a room, because it's the easiest thing to work with. And go to logic, and we'll add a variable. And you can immediately see straight away that we've got these two extra controls here, but we'll just create an array variable with 100 entries. So you can see straight away it shows up as the name A with the number of the size of the array in square brackets. So that just basically allows you to have a single variable contain a number of values. And the thing, if you drag in a get set node, you'll see we've got this additional control here. So before the get just had the name of the variable, it would just get the value out here. But now you can decide which index in an array. It uses exactly the same node for accessing an array, a variable that isn't an array, just the index is ignored, just to keep things simple. And the same for set, you can set the index 0 to 99 in this example because it's 0 indexed. And most importantly, the index is an input port as well, so you can do things like looping over variables, or you can choose the particular index in an array based on some other calculation and access variables that way. So it's quite powerful tool. Now, moving straight on to the next feature, which is variables initialized or uninitialized, which is another flag that's been introduced here. Now, the reason it was introduced is related in many ways to the introduction of variables, array variables. Excuse me. The introduction of array variables basically meant it was very easy to very quickly create a large array, variable space that would use a lot of memory. Now, one of the things that Kwyll does for logic is, for all the variables that you define in a particular logic graph, it outputs double the amount of space. And the reason being is that it needs to be able to reset the game to a start state when you do a reset game. Or so for example, if you die in your game and it's game over, it needs to be able to reset to a known state. So you'll have seen this if we quickly go to the map and drag our room into the map so that it's there, and you open this variables list here would normally be populated with all the variables in that room definition for you to set default values. Now, as you can see, it's empty here, and the reason is the initialized variable, the initialized flag, is not set. So what this means is it will only output, in this particular case, it'll output 200 bytes of space for the variable to use at runtime, which is what it would always have done. But it would previously have also output another 200 bytes of space, or taken up 200 bytes of space in the output buffer to store the default values, the initial values that then get copied into the runtime values, the live values, when you reset the game. Now, quite often it's not necessary to be able to reinitialize variables at start. Variables are often used purely for holding data during runtime, and their initial state is either irrelevant or is perfectly okay at 0. Kwyll will set all variables, array or otherwise, to 0 at the very start at initialization. So if 0 is okay, or if you've got some code on the initialize trigger that sets variables to certain known values, you don't need to store default values for them. Or if there's just no reason for it to be in any particular state, if it's a counter or it's something that's used to store the result of a calculation elsewhere, its initial state doesn't matter. Then you're wasting a lot of memory. And it's especially relevant when you're dealing with large variables. As I say, this would have taken up 400 bytes of space before, but by marking it not initialized, it can be reduced by half. And just to show you the effect, so if I leave that as is and do an export, you see it's 472 bytes. If I mark it as initialized, two things happen. Firstly, in the map, if we edit this now, it exposes all of those initialized variables, so I can set values for these to whatever I want them to be. But the second thing happens is, if you look, this is 472, it becomes 672 because it's outputting another 200 bytes of space into the buffer for storing the initial value of that variable. And if you don't need it, turn it off. By default, it will be off. So if you create new variables now and then you go into either the map and open it up and you see that your variable is not there, that's the reason. And the same thing applies if you create an object type and then you drag that either into the map or a room. The object properties will not show any variables that aren't marked as initialized. There's some new tiles, new nodes. So the first one is touch tile. So this is a new trigger type. This will fire, the event will fire if the object on which this trigger, it's only available as an object trigger, this flows on, touches the bounding box of the object, touches a tile with a non-zero type. So if you remember, if we go back to here, we had a tile and set its properties. The default type of a tile is 0, but you can set it to something else. So if you then use that tile and then your object touches it, this trigger will be fired along with the type and the X and Y tile position of the tile that it touched. So with this one loaded, I can show you it in action. So if we go to our rooms and look at the room, I've got a couple of tiles types in here in particular. I've got the boundary, but I've got this collectible thing, which is tile type 2, and the spikes, which are tile type 1. So if you look at the logic for the player, you can see we've got a touch tile trigger coming in here. It sets some instruments just for debug purposes, and then it checks to see if it's tile type 1. If it does, it beeps to say that you've been hurt. If it's not tile type 1 but it is tile type 2, this is coming from the input of the touch tile trigger, then it plays a different sound and it clears that tile to say that you've collected it. Then you could add to your score or whatever. So if we look at this in action, as we move the player around, as you get over the thing, it shows you the coordinates of which tile was collected and collects it, and if you touch the red one, it plays a sound to say that you're. So this is a combination of the introduction of a new node and the deprecation of a previous node. So if we do so this is a new node that does a loop, a tight loop internally over for each tile in a region, a position in tile coordinates and a width in tile coordinates. So you can specify a square or a rectangle area on your tile map to scan over and do something with, and it could be reading that tile, it could be changing that tile, it could be doing anything you like, but it just very quick way of iterating over that rectangle, row first and then column. It replaces the old modify tiles node, which I'll put a copy of up here because I can't actually create one anymore because deprecated nodes aren't available, but I'll post up in the corner somewhere a picture of what it looked like. And it was a pretty complex node. It had these XY, it had actually X2 and Y2, so it was the coordinates of the two extremes. But then it didn't have a body, it would just basically allow you to set the tile color information and collision information of every tile in that region to a specific one thing, which wasn't particularly flexible. It was good if you wanted to clear a section, all you wanted to do was clear the tiles, but if you wanted to change a section of the tile map to something or query the tile map, just not possible. So you'd end up having to use a brush and paste brush to place anything more complex. This node allows you to be a little bit more nuanced in your controls. So you have this loop, this function, this node which will loop over each one and output in here X and Y of each tile within that region, and then you've got new tile nodes for set tile and set tile color, set tile collision. So then you can do any combination of these. So we could, in the body, we could set the tile X and Y to clear it, and then we could set the color of X and Y to let's do paper to purple, and then you can set the collision to off as well, for example. And of course any of these things, grab the X and Y again, any of these 3 nodes here, so if you set it to collide on everything, any of these 3 nodes here can get their values for the tile number, the collision information, or the colours from any other part of your calculations. So you can have a fairly complex set of operations that changes the region of your tile map based on all sorts of things. On the Spectrum side, lots and lots of changes. The entire engine has been converted to pure Z80. There's no more C. It was started out with written in C a long time ago on the Z88 DK toolchain, and then slowly over the last few months I've transitioned component by component into hand-coded Z80, and then in this last push, in the last maybe month or so, I've completely eradicated all C from the Spectrum engine. It's now written entirely in Z80. It doesn't rely on any C standard libraries. It can actually be assembled now with any assembler because everything's in there. So for example, even after transferring the C into Z80, it would still rely on things like the Z88 DK's multiply and divide routines. So I've now replaced those with my own multiply and divide routines written in hand-tuned Z80. So it's all internal. Every piece of the engine is specific to Kwyll now, not to any particular tool chain. That's important. It means I have much more freedom to go in and tune and tweak things. But alongside that, another major change, which is much more visible to the end user, is because no longer does it rely on C, using the C toolchain to build the exported game seemed silly, unnecessary. It would basically be taking a header file, compiling that single header file into a data block, and then linking it with the pre-compiled engine code. So instead I've come up with a way of avoiding that altogether. So it no longer outputs, Kwyll no longer outputs a header file, a C header file that gets compiled. It outputs directly a binary file, so effectively skipping the step of compiling that header file into a binary. It exports directly to binary, and then I've got a very simple set of code in Kwyll that will take that binary plus the pre-compiled engine code, mash them together, and then create you a tap file. So to all intents and purposes, the export now is instantaneous, far faster than it ever was before. There's no longer any need to download a toolchain, so you can get Kwyll, install it, and there's no further downloads, no further requirements. I don't need any storage for different versions of the toolchain for different operating systems. Everything's handled in Kwyll, which is much nicer. It does have another side effect, so because I'm building the tap file directly from within Kwyll, I can also build other types. So it now exports a .sna file, a snapshot file as well, which could be useful if you don't want to have the tap file. You can just load a memory dump, so it saves both of those. So that's useful. That brought with it a bunch of other optimizations in both the way that the code works and the way that the data exports. So again, we're squeezing more available memory out of the system. And I can give you some stats on that. So at version 0.0.132.1, which was the version that was live at the last update, the 36 update on the 26th of October, the amount of available room for your game was 10,468 bytes. As of 1.0.1.3.0, which is the current live version, it's 12,898 bytes. So an increase in available space of 2,430 bytes. So an extra 2.5K effectively to build your game in. So that's really important. So that's all good. And of course, all of these optimizations bring with them some performance optimizations as well. Optimizing the code dramatically to that degree inevitably ends up having positive impact on the performance on the Spectrum 2. So just to finish up, I'd like to take the opportunity again to thank everyone who supports the project on Patreon and Ko-fi. Your continued support is what keeps the project moving and gives me the impetus to continue developing it. So I'd like to recognise all of those people by showing the names on the screen now. Once again, thanks very much for your continued support. Anyone else who wants to support the project, pop over to the Patreon or the Ko-fi page, and your contributions will be very welcome. So that's it for this time, I think. As usual, if you like it and you're interested in keeping up to date with what's happening with Kwyll, don't forget to subscribe and leave a like if you like what you're seeing, and I'll see you next time.